Welcome to All About AI. In this lesson, we will have understanding about artificial intelligence. I am going to cover here what is AI, examples of AI in everyday life, vital parts of AI, machine learning and conventional programming key difference, brief history of AI, key figures in AI history. So what is AI? Before we start to discuss about what is AI, it's important for us to understand what is human intelligence. So usually when you say human intelligence, humans have many capabilities. They have intelligence around logical thinking, analytical, visual, linguistic, creativity, spatial, strategic, learning, kinesthetic, interpersonal, intrapersonal, musical, and many more. Now, artificial intelligence refers to simulation of human intelligence in machines that are programmed to think and learn like humans. So if you refer to the keywords, it's a simulation. It's simulating human behavior to think and learn. So AI is about learning, problem solving, decision making, perception, and bringing in autonomy. So when a machine or program is able to learn, do problem solving, or do decision making, or have perception capability, or have some kind of autonomy, or a combination of some of these, we call this program or machine as intelligent. And overall, this concept is called artificial intelligence. Now, before we dive in, it's important for us to look into some of the recent examples, and you will appreciate that in our everyday life we have so much usage of AI. Let's go through few recent examples of AI in our day-to-day life. Image recognition and computer vision. This is the AI area focusing on enabling machine to see and understand the visual world. I think many of us are using Google Photos that automatically organize based on people, place, objects. It can detect a lot of things and help us to organize our photos. Similarly, natural language processing. This is the area which deals with machine understanding and generating human language. One good example is Amazon Alexa. Alexa uses NLP to understand voice commands, answer questions, and interact with users in a natural way. Machine translation. This subfield of NLP focuses on translating languages automatically. I'm sure many of us have used Google Translate. Google Translate use machine translation algorithms to convert text from one language to another. Another good example is recommender systems. This is the field of AI which focuses on recommending product, service, or content to user based on their preference and past behavior. In case of Netflix, user recommender system is used to suggest new movies or TV shows that user might have enjoyed based on his or her watch history. Next example would be robotics. This is the field which combines AI, engineering, and computer science to design and build intelligent machine that can perform various tasks. One good example would be Atlas robot from Boston Dynamics. Atlas is a humanoid robot that can perform complex tasks like backflips. Next example would be self-driving cars. This is a field which has progressed a lot over last decade. This area focuses developing autonomous vehicle that can navigate and operate without human input. Tesla Autopilot is one example of autonomous vehicle, though it's not fully self-driving at this stage, but it can assist driver in various tasks like lane centering, automatic emergency braking, and many more. It uses cameras, radar, and AI to build this intelligence. Next example I would like to make is about image generator. This area focuses on AI systems that can create new content such as image or text or music. DALL-E 2 from OpenAI is good example. DALL-E 2 is a powerful generative AI model that can create realistic image based on text description. Another example is chatbots that can simulate conversation with humans. I'm sure many of you have used ChatGPT from OpenAI or Gemini from Google. All these are good examples of generative AI utilizing chatbots. Next example is game playing AI. This area focuses on developing AI agents that can play games at a superhuman level. I'm sure you might have heard name of AlphaGo from DeepMind that beat world champion in the complex strategy game called Go. Similarly, we have healthcare diagnosis system like IBM Watson, which use AI for diagnosis and treatment purpose. Now it's important to understand what are the vital parts of AI. I would like to draw an analogy with car. If you refer car, there are two very important things that play a vital role. Those are fuel. So either you will have oil or electricity, and the next very important one is the engine. So without these two, the car won't work. So if I make the similar analogy and treat car as a metaphor for AI, then fuel or oil or electricity is nothing but the data in AI context. So data plays the same role as fuel, and it's extremely important. And like engine is the model or algorithm which ultimately drives the AI. So this is applicable for every AI, any branch of AI. Now, if we particularly focus on machine learning or deep learning, one more thing has played a vital role in last decade or so, and that's, you can think like a turbocharger in a car. Yes, we are talking about deep learning revolution that happened since 2010 or 2012 onwards. The equivalent turbocharger in deep learning is GPU, or special purpose hardware meant for tensor processing. These are the special AI hardware built specifically for very high intensity computing for deep learning, GPU, TPU, and many more. And this is the space which really turbocharged machine learning and deep learning, and all this revolution in AI started. This GPU is the reason why we can see Nvidia has become one of the top company in terms of market capitalization. They are now 2 trillion plus company. Let's revisit all the branches of artificial intelligence. AI can be categorized into two broader categories. One is machine learning based and another one is traditional AI. So machine learning algorithms, deep learning, computer vision, natural language processing, generative AI, all these are part of machine learning family. Traditional programming based are mainly coming from robotics, search algorithms, expert systems, fuzzy logic, evolutionary computation, swarm intelligence, planning and scheduling. These are broad categorization for easy reference. There are a lot of overlap, but for our learning journey, we'll be predominantly focused on machine learning based AI. We'll also cover to some details some of these traditional AI approaches as well. Next, I would like to draw a quick comparison between conventional programming and machine learning based programming. So in conventional programming, we see the data and program is being used, and usually there will be outcome as a result. So in conventional programming paradigm, we'll be using data and we'll be writing program to come up with result. Now in contrast, for machine learning, we'll see the data and result is being fed to come up with program. So there is a big difference the way both the paradigms are working, and you will see this makes machine learning a generalized programming environment, and many call it programming 2.0. We have come across a long way since the term AI was coined. Let's quickly go through all key milestones in AI history. The birth of AI happened in Dartmouth Conference in 1956. In 1958, we saw development of the perceptron, which is the initial building block for deep learning. We saw introduction of backpropagation algorithm, which is the vital part of deep learning. It was in 1986. In 1997, IBM Deep Blue defeats world chess champion. It was a giant step forward in AI journey. In 2012, AlexNet, at a deep learning model using GPU hardware, wins the ImageNet competition in huge margin compared to the second position. And that started the deep learning revolution, and AI again came into the forefront of technological innovation. In 2016, Google DeepMind's AlphaGo defeats Go champion. This was a huge breakthrough because Go is a strategy game and it's extremely complex. It was never thought that machine or program can achieve that kind of capability. 2017 was another key milestone in AI journey. It was the introduction of transformer model, which changed the entire AI world forever. In 2020, we saw release of GPT-3 by OpenAI, and this started the era of generative AI. Now I'll quickly go through few key figures in AI history, those who immensely contributed in development of AI. Alan Turing. He is considered as the father of theoretical computer science and artificial intelligence. He is the one who proposed the Turing test, a test of machine's ability to exhibit intelligent behavior equivalent to or indistinguishable from that of a human. Next, I'll talk about John McCarthy. He is the one who coined the term artificial intelligence at Dartmouth Workshop, a landmark event that formally established AI as a field of scientific research. He made significant contribution to logic programming and reasoning systems. He was also advocating the importance of symbolic AI, a branch of AI focusing on knowledge representation and reasoning. Next, I would talk about Marvin Minsky. He pioneered the research in neural networks, a type of artificial intelligence inspired by the structure and function of human brain. He also co-authored the book Perceptrons, a foundational work in the field of neural networks. Next, I will talk about John von Neumann. He is a very well-known mathematician and computer scientist who made significant contributions to various fields, including AI. His work on computer architecture and information theory influenced the development of AI hardware and software. He proposed the concept of self-replicating automation, an early theoretical explanation of machine intelligence. Geoffrey Hinton. Many consider him as the father of deep learning. He is a very well-known leading figure in the AI field who was responsible for reviving deep learning. His research on backpropagation, a training algorithm for neural networks, was instrumental in overcoming limitations that hindered the field for decades. He continued to influence the development of deep learning. So, in summary, in this lesson, we have gone through how AI is machines and programs mimicking human abilities. We have gone through a few examples of AI usage in our everyday life. We talked about data, algorithm, and computing processor like GPU. We talked about machine learning is programming 2.0. We have briefly gone through history of AI and key figures in AI history.